All right, I'm trying to find the volume of the region bounded by the curves y equals x and y equals x squared when that region is rotated about the line y equals 2. Y equals x and y equals x squared. So y equals x, we've got 0, 0, 1, 1, 2, 2. Connect to those points. And y equals x squared would be 0, 0, 1, 1, 2, 4. And so I'll connect to those points. And I want the region bounded by these two curves. So this is not an obvious question because there is lots of area between these two curves. So this area here just continues forever, right? It keeps going and going and going. That is unbounded. So that is not the area I'm looking for because they asked for the area bounded by the curves. So that is an unbounded area, so that's not the area I want. And the same thing happens over here. There's some unbounded area, so it's not that. So what the area is between the two curves, this little sliver. That's the only bounded area between y equals x and y equals x squared. So I want to rotate that area about the line y equals 2. So now I'll sketch that line in because I didn't draw it before because I didn't want to get confused about what my bound lines are and what my axis of rotation is. Okay, so I'm going to draw a little representative rectangle perpendicular to the axis of rotation somewhere in my generating region. So I've got a little rectangle right here. And that is at a random location, x sub I, somewhere within the region. I drew a representative rectangle. When I rotate about the axis of revolution, I am going to land somewhere like here. A little rectangle will reflect over there. And it's going to create a washer. So we've got a terrible picture of a washer. There we go. All right, so the center of my washer is right here at y equals 2. And my inner radius is the distance from the center to the closest point on the representative rectangle. So that green distance is my little r. Jot that over here. So that is the distance from y equals 2 to y equals x. So it is 2 minus x. And then big R, do that in another color. Big R, that's the distance from the center to the far end of my representative rectangle. That distance, that's the distance from y equals 2 to y equals x squared. So it's 2 minus x squared. So the volume of my washer, which is pi r squared minus pi little r squared times thickness. Okay, so this is pi times big R, which is 2 minus x squared squared, minus pi times little r, 2 minus x squared, times thickness of the washer. And that's the thickness of the washer is the thickness of the little representative rectangle, which is delta x. Okay, so that is the volume of a single washer. Then I want to calculate the volume of all the washers, which means just add n of these up. And then the exact volume, I take a limit as the number of washers goes to infinity. So this is the limit as n goes to infinity of the sum of all the washers. And that's the definition of an integral. So this is the integral. I drop the sub i's, which I forgot to write in the first place. So this becomes pi times 2 minus x squared minus pi times 2 minus x squared. My delta x becomes a dx, and my bounds of integration go from 0 to 1. That's where all these little representative rectangles are sweeping out washers that I am stacking up between 0 and 1.